look at a couple examples. So this first one, they say cis of pi over 5 times cis of 3 pi over 10. And we just learned a second ago that we can, when we're multiplying our complex numbers in polar form, we can add I just forgot, the argument. That's what we call that. That angle right there is called the argument when we're talking complex numbers. And so this becomes cis of pi over 5 plus 3 pi over 10. Okay, hopefully this works out nicely. This is 2 over 10 plus 3 over 10 is 5 pi over 10. Oh, that looks familiar. So this is this equals cis of pi over 2. And what they want us to do is they want us to, typically we end up in the form, in the rectangular form, a plus bi. Okay, so this becomes cosine of pi over 2 plus I sine of pi over 2. And you know your unit circle. Cosine of pi over 2, that's the x value is 0, plus sine of pi over 2, that's 1, so it's just times I times 1. And this is just equal to I. Okay, let's look at one where if we divided, so the next one that the book has us work through is cis of, I lied. Okay, so it's pi over 5, that's pi over 5, divided by cis of 7 pi over 10. Okay, and we talked before about how in this situation we can subtract our arguments. Okay, this becomes 2 over 10. Well, here I'll write it out. 2 pi over 10 minus 7 pi over 10. That looks familiar too. This is cis now of negative 5 over 10 is pi over 2. Okay, which is cosine of negative pi over 2, which is 0, plus I sine of negative pi over 2. Negative pi over 2 is down here. Its y value is negative 1, so this is plus I times negative 1. And so this answer would equal negative I. Okay, last part of this example, real fast. So here, 1, 2, and here comes 3. If they give us a problem, say they do something like this. 1 plus root 3i times root 3 plus I. And I want to multiply those together, and I don't want to, but using polar. What I know here is 1 plus root 3, so this becomes a triangle here. This is 1, this is root 3. This is a 30, 60, 90 triangle. So 1 root 3, and this becomes 2. So then here is, you can think in terms of the 30-degree angle is up here, so this is 60, which is pi over 3. So this first number here, 1 plus root 3i is equal to 2 cis pi over 3. And then the other one, I don't know where to write it. Here we go. The other one is this root 3 plus I. So this is root 3, this is 1. And so this is 1 root 3, this is 2. So here it's still a 30, 60, 90 triangle, except instead of it being pi over 3, this is now pi over 6. Because that's the 30. So this one, root 3 plus I, would actually be equal to 2 cis pi over 6. Okay, so for multiplying those, we have 2 cis pi over 3 times 2 cis pi over 6. Well, 2 times 2 gives me 4. And this is cis, we add these. This is 2 over 6 plus 1 over 6 is 3 pi over 6. Right, in case you forgot, pi over 3 plus pi over 6 will actually equal, that's 2 over 6 plus 1 over 6 is 3 over 6, which is pi over 2. Okay, so this becomes 4 times cosine of pi over 2 plus I sine pi over 2. Pi over 2 has a y value of 1 and an x value of 0. So this is 4 times 0 plus I. So this is just 4i. Okay, if I were to expand that out from before, what was it? It was 1 plus root 3i times root 3 plus I. It gets a little messy. This is root 3 plus I plus 3i, when I multiply these together, plus root 3i squared, which becomes a -1. So these cancel, and I end up with 4i. So that wasn't so terrible, but there are definitely going to be situations where it makes a whole lot easier. Or if I had given you one of them in polar form and the other in Cartesian, it's easier to put them both into the polar form. There are more videos coming, so stay with me.